So pass by value versus pass by reference is historically been like one of the is historically been one of the trickier concepts, just because of how kind of in some cases it's not very transparent what's happening. I think in JavaScript there's kind of a tendency to assume certain things work, and this is definitely one of them. So the slides kind of presented one way. I like to do it on the whiteboard because I think it really makes kind of like to our discussion yesterday. Like if I just show you a slide and say this is how it works, people might nod and say, oh yeah, that kind of makes sense. But then if I make you draw it on the whiteboard, then there's zero ambiguity about whether or not it works because you're drawing everything from scratch, which is ideally how we want to learn as many of these concepts as possible. So I guess like the way I would think about pass by reference versus pass by value, right? So what does reference versus value mean? So if I could draw if I separate this whiteboard into two halves, on the left half we'll call it I'll call it variable land, like a theme park. And then here, I guess we can make that a theme park name, but I'll probably just call it computer memory. A much lamer theme park name. Alright, cool. And so the reason why I differentiate between these two things is because what we think of as a variable and what we think as something's value. Actually, I'll call it value land. I think that may be a better way to think about it. Because I think technically everything exists in memory, right? So value land, it's like the budget version of variable land. Okay, cool. So if I write a statement so if I write a statement like var x equals 6, right? In essence, what we're really saying is, hey, we have this variable here, we'll call it x. And here we have a value called 6, right? And essentially what we're doing is we're drawing, we're saying, hey, variable, you're quote unquote pointing to 6. Make sense so far? Good. On the other hand, so let's just say I wrote something called variable x equals 6. What if on the bottom now I wrote something like, okay, great, now var y is also equal to 6. What happens now? Better yet, or draw this diagram for me out in a way. Who wants to draw? Great, awesome, there you go. I'll find more markers. Okay, so you're saying that x and y are referencing the same exact thing.
I think so.
Cool, leave the marker there. And as something that I will probably do continuously for the rest of this lecture, rather than just saying, oh, you're right or you're wrong, we can test it out. Because this is, ultimately this is the litmus test actually matters, right? Okay, so let's say we have var x equals 6, and then, and then down here, I'll just copy and paste this. We have var y equals 6. Okay, so I'm not going to say right away whether or not this is right or wrong, right? But let's say now, I should space out the board a little bit better here. Let's just say okay. Let's say over here I have another variable, right? And I say var a is equal to this array of 1, 2, 3, right? Support array, 3 numbers. The way to draw that is pretty simple, right? I have a variable called a here, and obviously this is fundamentally different. They couldn't possibly be the same thing. So now I have this array called 1, 2, 3, and I draw an arrow from here to here. Make sense so far? Great. So now if I have something called var b also equals to 1, 2, 3. Someone want to draw me the arrow that I kind of went over, but you can kind of assume where the right back. Now who wants to draw me a diagram for where var b points to? And if no one wants to volunteer, I'll just volunteer you. It's pretty straightforward. Great. And you're next then. Thanks. Okay, great. And so you're saying var var b now is equal to something completely different.
Mm-hmm.
Not going to do the same thing. Okay, great. And then Kelly, because you volunteered. What if I now create a variable called var c, and this is equal to a. And we'll do this thing for different over. I forgot about it. We're just coming back to it. Okay, but so sorry. So anything that exists in variable land can't exist in value land, right? Because a is just representing something, right? So yeah, so we can't do this. Okay, so you. Right? Cool. Okay, and then here, so now going back to the numbers one, I'll do var z is equal to x. Who wants to draw that one? Okay, here it is. You just write you can write z right here. Sorry, I did space on it. Z, yeah, var z equals x. Yeah, cool. Okay, cool. So basically, in this case, we have var x, y, z are all pointing to this number 6, and then var a is pointing to an array with values 1, 2, 3. Var b is pointing to its own array of value 1, 2, 3, and var c is actually pointing to the same exact array as var a. Okay. Cool. All right. So I guess let's talk about the assumptions we're making for x, y, and z, right? And then here we have var z equals x. Okay. So if that is true, if this is true, right? And let's say lower down on it. So we're just focusing on the top part now, x, y, z, right? Let's say at some point I say, oh, by the way, x equals 7. Okay. I know I don't want x equals 6. I want x to equal 7. What do you think happens to y and z? Someone draw it out for me? Yeah. Great. Here's an eraser if you want to undo some of the previous stuff.
What happens to both y and z?
Yeah. So let's just say let's make this 7. Let's write this 7 now. And so now the question is, what happens to y and z? Are they 6? Are they still 6, or are they 7?
I think it's 6.
Draw it out for me. Okay, cool. All right. So to put that in code form here, if I console.log out, let's say x, right? I'll actually just put it as so I'll say original x is equal to x, and then I'll copy the same thing for y and z. Oh. Okay, and then I'll also console log out a bunch of lines here because we're going to be printing out a lot of things in the very near future. Okay, cool. So original x, original y, original z. Now the thought process is, okay, I want to do the same exact thing, except now I want to say x is equal to 7. Cool? Everyone's apart? So by that logic, x should be 7, y should be 6, and then z should be 6, right? And so we console log it out. Okay, so far this model kind of holds true, right? We're seeing it, we change x and everything's coming back correctly. Okay, now let's take a look at the one for the arrays down there. So let's see what the best way to do. So actually, I'll copy this. I'll make a new repo for this just for the arrays part. Okay, and so instead of 6, we now have something called 1, 2, 3. This is now A, B. If I just leave it as x, y, z, can you follow along pretty well, or do I need to retype? Should I retype it? I can leave it like that? Okay. All right, cool. So here, everything is the exact same, right? If I don't do anything down here yet, I print out, okay, great, my arrays are 1, 2, 3, 1, 2, 3, and 1, 2, 3. Everything's like, makes perfect sense. And then the question now is, what if I suddenly change this to, 4, 5, 6? So who wants to go draw out on the whiteboard what happens then? Or what they think is going to happen then once we reassign A? Great. Good.
Okay, wait, we're reassigning.
Yep.
A is X, right?
Right. So basically assume that, up until now we've done lines 1, 2, 3. And then I'm suddenly going to do line 4. Or sorry, line 10. Okay, cool. Awesome. So I print it out. We get something that's roughly kind of in line, right? Or do we?
Oh, no.
What's wrong with this console log?
Only X changed.
You would have to.
Only X changed.
Yes. Well, yeah. So only X changed in this case, right? So in the previous one, or rather, I guess if you follow the diagram we have there, right? So Claire changed 1, 2, 3 to 4, 5, 6, right? So A and C, technically X and Z, whatever, we have them pointing to the same exact thing, right? But that hasn't been the case. So why is that?
Is it because Z is pointing to at X, which at the time was 1, 2, 3, and because the 4, 5, 6 modification hadn't been done yet, so it didn't exist when Z was defined? Does it have to do with like placement?
It doesn't have to do with it does have to do with the order in which we assign things,
right,
but not in the necessarily the way that you were describing kind of explicitly. Okay, so maybe this is actually a good point to just maybe jump into the slides really quick so we can kind of see more examples of this. But essentially, this is kind of why I'm saying it's confusing is because if you notice for different data types, essentially different things happen, right? There's just a concept called pass by reference versus pass by value. Okay, if you think about what those words mean, reference and value, the string 6 is a primitive, or the number 6 even, right? It's a primitive data type, right? It can't change. 6 is always going to be 6. The string hello is always going to be this. Is always going to be the string hello. So those things never change, right? And so if I have something that never changes, and I say, hey, by the way, why don't if I'm A and I say, hey, my value is the number 6, and someone else wants to say, hey, David, I also want to be 6. At that point, what's happening is I'm actually not linking myself, or rather, what I'm saying is, hey, rather than you sharing my version of 6, why don't you take your own version? Because guess what? 6 is always going to be 6. And so you have your own version of 6, and I have my own version of 6. Okay? And it's the same reason why, in that case, in the numbers up there, I'll erase all of that, and I'll redraw the diagram again so you can see it in a little bit. But essentially, for primitive data types, what happens is we always pass it by value. As in, and this is actually what we're really seeing in JavaScript, which is that for primitive data types, 2 variables cannot point to the same primitive data type because the computer does not allow it. And so anytime you see var x equals 6 and var y equals x, just know that in that case, what's actually happening is they are pointing to the same value, so to speak, but the values are distinct. They're not linked. Okay. Now, if we move over now to kind of object land, right, or array land, or whatever you want to call it, then it becomes a bit different because the main property of non-primitive types is that you can change them, right? And so it actually becomes very important that I keep reference to the value, or rather to that explicit variable. So let's go through the slides, and then hopefully this will kind of make a bit more sense. All right. Okay. So in this sample code snippet here, right, on line 1, we have an array. It's 1, 2, 3, right? And then we have another new array, and we set it equal to the old one. And then when we push 4, what's happening is new array and array, and we print out both new array and array. What do you expect to happen here? So I'll actually spell this out. Might be a little bit easier. So we'll figure out all this now. Okay, so I have this thing called ARR, and it's equal to, rather, it's referencing this array called 1, 2, 3, right? Cool. And now what's happening is when I have another variable called new ARR, is an array a primitive or non-primitive data type? Non-primitive. So do I want the value or do I want the actual thing?
Wait. What do you mean
Okay.
by that?
So remember what I talked about why the difference between value versus reference, right? Value is you give your own copy of whatever it is that I represent. And then reference is, hey, we can share the same exact thing.
Okay.
Right? So for an array is, do I want the value of this array or do I want the actual array?
Ref.
So the answers are either actual array or value of the array.
Actual.
Actual? Okay, so if I want the actual array, then this means new ARR basically has to point to this thing too, right? If I wanted the value of it, I would just make my own copy of it, right? But in this case, what you're all saying is, hey, I want the actual array. So by definition, they have to point to the same exact thing, right? So then, if I was to, on line 3 there, if I was to just go in and say, oh, by the way, let me change this array now. I want to add a 4 to it. If I console log out ARR now, it should clearly be 1, 2, 3, 4, right? But when I console log out new array on line 6, or again, they have a reverse, but essentially, line 6 is going to give us 1, 2, 3, 4, right? And that's pretty straightforward. This is, new array, I'm missing something this one. New array is pushing 4 to it, right? So basically what we're saying is, if new array pushes a 4 to it, right? We expect new array, when it console log out, to have 1, 2, 3, 4. Do we expect the original array to maintain 1, 2, 3, or do we also expect it to have 1, 2, 3, 4? Okay, so how many people think it maintains 1, 2, 3? How many people think it maintains, or it's now 1, 2, 3, 4? Okay, so maintains 1, 2, 3 or seconds. The majority of the class, and then how many people think it will actually now show 1, 2, 3, 4? Okay, I'm going to assume there was no overlap. Well, that looks suspicious. Okay. Well, so
Didn't we just do this?
So I guess in that case, the minority of the correct is pass was correct, right? You can think about it this way, right? If this is my diagram here, and if you're telling me, by the way, David, I want ARR and UARR to both look at the same exact object, right? And I change that object. Everyone who is looking at that should also be now seeing something different, right? Otherwise, otherwise, if new ARR was 1, 2, 3, 4, and AR was 1, 2, 3, then that means what? It means I was looking at 2 separate things the entire time. It's only I can change one and not the other, right? It's like 2 people are like holding 2 ends of the same stick, right? If I heat up that stick, theoretically both of them are getting burnt by it, right? If they're both holding a different stick, then I can heat one up and one person get burnt, but the other one wouldn't. Really weird example, sorry. But the concept kind of sticks, right? Like these 2 arrows means if I change this, then I mean the arrows kind of go both ways if you go, right? Like this is also gonna, if I ask you what array is gonna be, this is also gonna go back this way, right? And so in this case, by changing this one thing, the way we drew the diagram means that, well, they both have to change, right? And this essentially is kind of the root of pass by reference, right? Reference means is I am actually giving you the actual array in this case, but the actual object, right? We are looking at the same exact thing. When I say in line 2 there, when I say new ARR, this with ARR, I'm actually pointing to the same exact thing as ARR. Yeah.
If you wanted to mess with the array but you didn't want to change it, like say you wanted to, that's not what delete or something, but you wanted to leave 1, 2, 3 alone, how could you copy it to mess with it without damaging the original?
Yeah, let's talk about it at the very end, okay? Because I think that does come in a later slide, and it does become a very important question of, hey, how do I play around something without changing everyone else who also would have to be looking at it, right? Okay. Does that diagram right now make sense? Okay. So yeah, so this is passed by reference, right? Because reference means we're looking at the same exact thing, okay? On the other hand, this one I'm not going to spend too much time on because I think most people are actually pretty clear that these are two very different things, right? If I happen to have an array that matches 1, 2, 3, and a new array happens to a separate array of 1, 2, 3, I think most people are pretty clear that they are just two very different things, right? It's like having two people named David, right? Like, yes, their names are David, but they're clearly very different people. Okay, so that one I'm just gonna kind of leave as is. I don't think anyone gets too confused by that. So that one, when I change one array, obviously they're two separate things altogether. So changing one doesn't impact the other. Everyone kind of follow that one? Cool. All right, cool. Now this one on the right then. Okay, so once again, we go back to our old kind of setup, right? Where we have ARR is equal to 1, 2, 3. And then now I have something called new ARR is equal to array.slice. And then I do the same thing as before where I add a 4 to the new array. Okay, so I guess obviously we want to kind of take this from scratch, right? So ARR is equal to 1, 2, 3. This part is going to be the same, right? Now, who I guess wants to diagram out what happens in line 2 there? Or where does new ARR point to now? And it's a kind of thing where, like, I guess, I know you're all thinking about it, but also think about, like, hey, if I don't know what slice means, or if I want to understand slice better, where can I look to understand slice better? Right? This may not necessarily be only purely like a thinking problem here. Okay? So once someone wants to do the research they want, or think through it, and they want to come up with a diagram, how this looks. You want to do any? Yeah, go ahead. Where did the 4 come from?
The push form. Right?
Okay, so let's
Yeah,
let's stop at line 2 for now. Okay, so I'll just remove this 4 then. Okay, let's stop at line 2. Okay. So why did you make a new array?
From what I know about slide is that you take the value in the columns array and create a new array
Okay.
with the same value.
Okay. So I'll just look up the where it is.
That actually answers my other question. Can I copy?
I'm sorry?
So that would be the answer to my question.
Yep. So array.slice. We'll talk a little bit more about what shallow and deep means, but for now, just in your mind, they should be ignore that word more or less. Okay. So the slice method returns a shallow copy of a portion of array, or if you don't give it any arguments, it returns what? The whole array. Into a new array. And notice how like JavaScript, like the reason why that's so important, JavaScript even makes like an explicit sentence just in case you weren't reading very carefully. Like the original array will not be modified, right? And so the reason why this is actually super important for us is because if you're looking at something and you're setting it equal to an array, in most cases, if you want to test out or try something else, you almost always want to be creating backups or copies of the variables that you want, right? So if I go back to this slide now, here, essentially like what's actually happening is because JavaScript is actually evaluating this. So JavaScript reads from left to right, but just know that whenever it sees an equality sign, what it's kind of doing is it's actually evaluating the right-hand side of the equality sign first, and then it says, oh, by the way, what's on the left-hand side? We want to point to this, right? So the way that JavaScript is actually going to read that on line 2 there is it's going to say, okay, first of all, you want me to do an AR.slice, right? AR is here. What does it point to? Oh, it's pointing to this array, and you want to do a slice. So what that means is I'm actually going to create, I'll use the dot notation, but I'm actually going to create a copy of this array called 1, 2, 3. And remember, this is a new array, right? And then I'm going to move to the left-hand side of the equal sign and say, oh, and you wanted to capture this with this variable called new ARR. Okay, the charts look the same as what Andy drew, but I just want you guys to understand conceptually how a computer will go about doing this, right? Like when it sees array.slice, it actually makes a copy first, and then it says, oh, by the way, where should I store this value? Because if I don't store it, it just kind of disappears, right? It goes into the ether. But if I want to store the value, I now know that there's a variable called new array over there. And so because this is a whole new array now, it's clear that these two values are distinct. Which is why on line 3 there, when I say, okay, for new array, I want you to add an extra 4 into it. If we console log this out, I mean, this is in reverse order, but like this, but like essentially, like one of them is 1, 2, 3, and one of them is 1, 2, 3, 4, because once again, they're distinct now. There's no link between them, and dot slice kind of helps us get there. Okay. Any questions so far on this reference and on reference? Because I haven't really talked about values yet. No questions? Yeah.
One question. What is the difference for like when we did the REPL with the X and we had Y and Z going towards X?
The numbers, right?
Yeah. But it didn't. Only X changed. But for the case for the arrays, it does change.
Let's go through the next slide, which talks about primitive data types, so numbers, and then if you still have a question after that, we can draw it on the whiteboard. Sound good? Cool. And I just want to make sure, because I don't want to like jump too far ahead into something that we're going to talk about over the next 1 or 2 slides, most likely. Okay, cool. And so now we're going to see kind of really like the most common application, right? So normally, you know, when we do like var x equals this or var ARR equals this, it's pretty straightforward, right? Like we're declaring on a single line. But really, like in most of the things that we've dealt with, right, in every single problem set, you've always written a function, right? And the function's always taken what? What? I felt like everyone's made a big noise at once, and then no one actually said any words. It's like, Our function is taking arguments, right? And so when we pass in an argument into a function, that is like a prime example of how we're shuttling this thing back and forth, right? Because remember, if I have an argument that's a string, once it gets in, so here I have this this variable called array, right, on line 1 there. When I pass it into push4, what does it become? Within this function called push4, what does it become? Yes, but like before that. It becomes ARR.
Yeah.
Right?
Yeah.
Like that's a parameter, right? Like we took an argument and we made it to a parameter, right? Remember, and I always said about parameters, right? Imagine at every single line, right, of a function, we say var parameter name equals whatever the argument was, right? So in that case, we're never writing that equal sign, but we're also very like implicitly creating a new variable. I'm getting a few blank looks, so I know, and I really want to hammer this one home because this is like super critical. This is how you was. This is probably the most common place where like pass by reference versus pass by value kind of get mixed up here. Okay, if I have something called function like we'll also call it David, it takes in an argument called foo, and then all it does is console.log out foo, right? I have something called a var str equals name. And then here I invoke David str, right? Here, or actually, you know what? Let's make this into an array because we've only talked about array so far, so that way we don't get too confused, right? Let's say str is 1, 2, 3. I hate myself. Okay, there we go. ARR. Okay, cool. So if I run this now, it prints out 1, 2, 3, right? All I'm saying is over here, we have this kind of implicit statement that says, hey, by the way, from now on, we have this thing that's called, var foo is equal to ARR, right? And so putting it in context of what we've drawn here is, so in line 6, I've still created this var ARR equals 1, 2, 3, but on essentially line 2 there, what I'm doing is, actually, yeah, who wants to draw out for me how that looks with foo?
So So, what did you call again?
I mean, eventually, I have a variable called foo, right,
Uh-huh.
here, and it's got a point somewhere. So,
Okay. So, towards will eventually. Okay, you know, it's
Okay.
eventually happen towards.
okay, cool. So what you're saying is ARR and foo are different things.
I'm not sure.
So what kind of data type is ARR? As-
Array.
Is an array, right?
Yeah.
And is array primitive or non-primitive?
No.
Okay. And so does array, would we be passing it by the value of the array or the actual array itself if we ever want to move it anywhere, so to speak?
Would be the value. I think the value. No. Okay.
Because remember how earlier in the example, right, we did something like, like var x equals 1 comma 2 comma 3, right? And then someone else said, oh, well, what if we have var y equal to x? Oh, not that. And then we did x dot push 4, right? And then when we I'll just go to the slide actually, I'm just maybe retyping the entire thing, but like this line right here, like the first slide we saw, right?
Right.
Same idea. Var ARR is equal to 1, 2, 3. Same right there, right?
Yeah.
We had this thing called new ARR, which essentially is my version of foo. It's foo. And we're saying, hey, this is equal to ARR,
Yeah.
right? Just like how in the REPL earlier, here, right? Var foo or new ARR is equal to ARR. So maybe if it helps if I just reassign this name so that like it matches up with the earlier slide here. Cool. Like this is just a direct application in the first slide, right? So in this case, we talked about how with non-primitive data types, it's super important to us that we're actually referencing the same exact thing, right? Strings can't change, numbers can't change, but arrays can change, objects can change. And that's why it's so important to us that we're always maintaining focus on that actual object or that actual array.
This should be undefined. You have to change full to a new one.
Oh, did I? Yeah.
Sorry.
No, it's fine. No, if that's a sort of confusion, then definitely don't want that. Okay, cool. Okay, so I guess if we agree as a group then that or if I just say that, with arrays we want to pass by reference, as in we want to pass the actual thing back and forth now. How does that change your arrows?
You're pointing at the same thing.
Yeah,
Okay.
that's it.
And this is the reason why if I was to log out new ARR, right, it says 1, 2, 3, 4, and so here's like the really cool thing, right? What if now I say, by the way, I want to do how should I? Well, if I do AR.push 4, what happens?
New arrays 1, 2, 3, 4.
What's new array in that case?
1, 2, 3, 4.
Cool. And so now I guess here's like trying to be a little bit trickier now, right? What if I want to console log out ARR down here, right? So I'll say, final. Okay. Right now when I console log out, it's 1, 2, 3, right? I define it, I never change it, right? But what if in here I now actually don't do this? I actually say, hey, why don't we change new ARR.push and we add a 4 to it? What happens then? What prints out on line 10? Is it 1, 2, 3 or 1, 2, 3, 4?
1, 2, 3.
Okay. Does anyone want to diagram out for me on the board how that happens? Did you take a eraser?
Oh, I put it on my.
Oh, okay. Okay. So I mean, I guess we'll go back to world in which this is called UAR. Okay, so I'll start this off now. So now we have something called new ARR. Okay, so on line 7 there, ARR is 1, 2, 3, right? That hasn't changed. We've been universally about that. Now the question is, someone diagram out for me where new ARR points to, and then also tell me what line 10 is going to give me when I print out ARR. Kevin? So tell me which line you're going to work on before you start writing, so as a group can kind of follow along. Line 4, okay. Well, so let's do line 2 first, right? Because before we get to line 4, we have to go through line 2.
I'm thinking it's still
Okay. Well, I mean, so that's your version of line 2, right? Or sorry, line 2, and then you did line 4 as well, right? You added the 4 to the end of it. So I guess if you're done with everything else, then what prints out on line 10 then? Is it 1, 2, 3, or 1, 2, 3, 4? Well, if you drew a diagram correctly, that's the only thing it possibly be, right? Because there's not 1, 2, 3 on there anymore. But who here thinks it's 1, 2, 3? Shatavia, why?
But I would think, because as you said, the original, it goes, well, it would print 1, 2, 3, but
You're talking more and more quietly as you go along, and I have you start off really strong, and just kind of like show it off.
at first I thought that it would print 1, 2, 3, 4, but because no one created it, that you know, go back 1, 2, 3,
Wouldn't it print 1, 2, 3 because it creates a copy of itself before it changes? So
Okay.
if you're referencing back to that, it would print out 1, 2, 3.
Sure. So where is the copy being created, or which one?
Copies being created at middle array dot push because it's going to take the original array, and create a copy of itself before it adds the 4.
Okay. And so where can we go to prove that? So-
Where do we go to prove that?
Well, I mean, okay. I guess so your argument is that dot push actually creates a new version of the array.
Yes.
Okay. So let's just.
Oh, you want me to actually?
Well, no. I mean, I'll just put it on the board. It's the same thing, right?
Slides. Okay, so when you have one value, it has to have its own, but when you're changing an array, you can change the array. So then if you're printing it, it would be the same.
I'm sorry.
Sorry, I'm like thinking out loud
Yeah.
about like why, because like values have to have their own arrays can
Yeah.
change.
Cool.
So if you're requesting that
Yeah,
the
array
array
doesn't
equals the
need
first
that.
array,
Why not?
I still think I'm right.
Create a new copy.
But you can tell me if I'm wrong.
Well, I will. Don't worry.
Yeah, no,
Okay.
Same object.
So does it print back to 1, 2,
I
3?
think,
Okay. So this is the documentation for dot push, right? It says it adds one or more elements to the end of the array. But remember how in the previous one it said, hey, this returns a new array, this doesn't modify the original array. I'm not seeing that same language here. And I can tell you that it's because it doesn't create a new array, and it does in fact modify the original array. Right? If you remember the example slides we're looking at, right? This is just dot push. Right? If it created a new array, what would we need to do?
Slide.
Slice it.
Bruce,
Slide.
Well, if it was returning a new array, if it was a new array, we would need to do what?
create the brackets? I mean, put brackets.
No.
Wait, to do, if we get a new array to do what? I don't understand what we're trying to do.
Well, if this created a new array, wouldn't this line do nothing? Okay. Remember, when we create a new array, what happens to that new thing?
It
Okay.
separates from the original.
It's a
Not
The
quite.
copy, makes a copy.
No. Not okay. Where I'm going with this is that remember how whenever we make a new array, we have to store it somewhere,
Oh,
right? In a variable.
Right.
If this is going to give you a new array, I don't see an equal sign here, so we're not storing anything. So even if this creates a new array, this line is completely useless, right? We do something, it doesn't change the original array, it produces a new array, and we don't store it anywhere. So we might as well have not done anything at all.
Good.
Make sense? Okay, so when I see this syntax here, and assuming this code is properly written, I can kind of make an assumption, well, if the author of the code wrote that, and maybe it's an unsafe assumption, but really like when I see that, this tells me that, okay, the fact that I'm not returning anything new and capturing a new variable probably means that this is doing something to the original array. Otherwise, I would need to capture that change somewhere. Make sense?
Yes.
Okay, so that's kind of where I was going with that train of thought there. Okay, so if I go back now to the problem, sorry Kevin, you've been standing up there for a while. Okay, so nope, not this guy, this guy. Okay, cool. So if we come back here now, I guess Andy drew that one on the bottom. So I mean that's the scenario in which I could see there being a 1, 2, 3 and a 1, 2, 3, 4, right? I guess like how should I phrase it? So I guess like we get to line 4 here, we add a 4 into it, right? And if I was just to say, hey, forget everything you've seen from lines 1 through 9, right? Assume lines 1 through 9 don't exist, okay? But really, all I showed you was this top diagram, not the one in English. All I showed you was this top diagram that we just made. If I console log out ARR, what is it? Exactly, right? So like this is like almost like don't kind of overthink this, right? Because essentially like if we drew that diagram correctly, then you just look at it and say, well, what's ARR then? Well, it's 1, 2, 3, 4. In fact, 1, 2, 3, 4 is the only thing on that board, right? Like we could almost make assumption there's no other possible values it could have been. Sorry, Jason, you have a question or?
I was going to say yeah, but I think we're having trouble drawing it.
Yeah, I mean, like, so this is why I really like this idea of drawing those diagrams, right? Because if you draw the diagrams the right way, like, in your mind, like, things can get shifted very easily, like, oh, I forgot what this is a reference to, and then you kind of get lost, right? But if you're drawing it out on paper, you can kind of retrace your step, it should lead you directly to the answer of, well, I want to log out ARR. Great, ARR, let's see what ARR points to. It points to 1, 2, 3, 4. Therefore, if my diagram is correct, then my console log has to also be correct. Okay? And so, once again, this is why this idea of pass by reference is really powerful and potentially really dangerous, right? Because, and so this is one of the things I've said it and you've all repeated it, but deep down, I'm not sure how much you guys actually realize like what you're saying, right? Like, what does it mean when two variables are referencing the same exact array? It means what you change to that array is going to affect those two variables in the same exact way, right? We have this variable called ARR, which is an array. We set new array here on line 2 equal to that array. So now both those variables, array and new array, are pointing to the same exact array. So it doesn't matter through which variable we change this array here, right? If we're doing array.push4 or new array.push4, at the end of the day, we're going to add a 4 here, and it's going to change all the other arrays, all the other variables that are mapped to it. Like, that's why like reference is really powerful, is because like you are literally changing the same thing, so it doesn't matter. Like, it's almost like saying like this is like a document, right? And these are now, like, think of like this as like a Google Doc, and these are all individual users, right? It doesn't matter who makes the edit. Everyone sees the changes come through. So now they can work, right? So in this case, like this array here, this is like the shared document, and these are all different users for different variables that reference it, right? If user 1 changes this array, and then user 2 changes this array, guess what? Both users are going to see each other's changes, because once again, you're looking at the same exact Google Doc. or same exact document, or in this case, you're looking at the same exact value, or sorry, same exact, we'll say value here, but like, you're looking at the same exact kind of value, right? But it's the same one, and that's why this is a reference. Like I'm not storing the raw value. I'm just storing a reference to a shared thing that everyone can see. All right, Claire, do you have a question? Like, raise your hand, or maybe that's Alex.
Oh, it was you.
Okay, sorry.
It was, but I lost my question.
Okay.
You said it powerful, but it's also could be dangerous, right?
It's extremely
If
dangerous.
one mistake, then you make the salary available to everyone to see.
Exactly, right? So if we look at this line here, right? If I just read through this line, and I see I'm calling on AR here, but then I never look to see what this David function is doing, on line 10, I would have no idea what's happening to ARR, right? And in this case, we're changing it, but the guy on line 10 here has no idea that ARR got changed. We added extra values to it. So this is why it's extremely, this is why it matters a lot that, you all really, really understand this. Like, when you're building these functions, when you're using arrays versus objects versus, primitives, you're very acutely aware of this. Because, this is the kind of thing where, you might not think about it too much, but, once you start writing the code and it breaks, you're going to need to be kind of on top of it to figure out, what went wrong. Okay. So far, we've only talked about pass by reference. Any questions? Yes, Alex?
So I think this is the question I want to ask. What happens if I want to push something but I don't want to alter the original array?
Okay.
Do I just have to look up a method that will do that? Is it do
yeah.
research?
How would you answer that question?
You can slice it and save it somewhere to the
that's
variable,
right.
then you can push that one.
So you have to make a copy.
Yeah.
Do something that makes it a copy.
Exactly, right?
Yeah.
So if both of those, so maybe let's just extend this Google Docs analogy a bit further, right? You're like, I want to use Google Docs so no one else sees it. Well, you have to copy it to your own document, right? On your own computer or whatever, and make the changes so no one can see it. As long as you're editing the same Google Doc, everyone by definition is going to see it, right? So that's what the dot slice kind of does, right? Is that it creates a new copy of the thing, and then if you want to reference that new thing now, that's entirely yours. You do whatever you want with it; it doesn't affect anyone else. But that does mean that you're basically breaking off this chain, right? The danger there is, and this is something that actually we don't talk about version control in this class, but you will in the full curriculum. It's actually a very, very deep common problem in engineering, right? Which is, well, let's say I have an app, right? And there's a million files of code there, right? But you have a team of 1,000 developers working on it all at once, right? Who has the latest version? Who has a master version? And it's actually a very deep intrinsic problem in programming. So in that case, if you say, hey, I want to have my own version of this array that I'll play around with and do things, that's great. But then you're also exposing yourself to the danger that if the group says, by the way, let's move to a new version of this Google Doc, let's make all these changes, you won't see those changes either, right? So whereas your changes won't impact others, you're also insulated from other people's changes, and so you're kind of only ever seeing half the picture, if you will. So you can't have it both ways. Either it's a two-way communication channel, which what you do affects everyone else, and vice versa, or you're completely segregated, and only what you do affects you, and no one else can affect you, or vice versa. Okay, so that's pass by reference. Okay, so we've only done with arrays, and the same logic applies for objects too, right? The same way we change an array by dot pushing, with an object, if I add a key, if I change a value, whatever, same exact idea, right? Because the object is a non-privileged data type, so whenever we talk about multiple variables referencing the same object, it is literally the same exact object. Okay? And then I guess the best way now to change this would be, okay, great. So rather than calling this AR, let's call this, we'll call this thing. We'll call this thing. We'll call this thing. And then this will now be new thing. Okay. Okay. Anyone confused so far? It's kind of serious though. I've just relabeled everything. I changed the word ARR to thing, right? Because now, rather than having thing be an array, what if I now make it a primitive? Now it's just a number. Okay. So now we're, as the name of the lecture indicates, we're now moving into pass by what? By value, right? So now it's actually super important that we're still on top of this, because guess what? Now we're no longer sharing the same exact thing anymore. Okay? So on that note, who feels like they want to diagram out like how this looks now with pass by value? Sorry, Kevin, I should let you sit down like 20 minutes ago. My bad, you've been there for a long time. Yeah, want to go do that? Yeah, no, erase all of that. Erase like that everything on that board. And just draw it out from scratch. Yeah. Great. So you're on line 2 now, right?
Right, so line 2. Are we still, it's not commented, but it's not commented out. We're,
Oh no, it's commented out because like we create a function and we create a parameter, JavaScript does it for you. So I'm just writing it out so you all can see it, but it's happening regardless of whether I put that there.
so the new thing, line 2, is
Huh?
8. And then you go to line 4.
Yep.
And that thing comes 9.
So then on line 10, what happens?
So on line 10, final thing is 8.
Okay,
Right?
that's
No, wait. Yes, 8.
so you're saying with 8. Okay, who thinks is 9 and is willing to go to the board and redraw a diagram to prove why it's 9? Your hand went down, Kathy, or Kelly, so I.
Yeah, I think it's 9. But I don't know.
You have a 50-50 shot because. Okay, got it. You think it's 8. Cool.
Do I sit down?
Have a seat, yeah, have a seat.
Great.
Okay, who wants to go up there and draw why they think it's 9?
Feel fun.
I mean, there's like 5 people who haven't gone up yet, so I'm gonna get to all of you eventually.
I did have to think it's not.
Right. Well, yeah, not for this one, but eventually it's really gonna come before. So does anyone think it's 9 then? What if you don't have to prove it? What if you just guess 9? Who thinks it's 9? Okay, so 3 votes for 9, but none of you want to actually explain why it's 9. You just are gonna just take a stab in the dark and say it's 9.
You just guess.
Well,
Because when,
Oh wow! Oh,
when,
never mind. Great.
When does it become, like when would it
You're
become
8.
then?
You're 8. You calm down. You've made your bed, so if you will. Yeah, Remy or Prita?
I think it's 9.
I got that part, but great.
Yeah.
Sure. Okay, so let's start at the beginning here. So what we're doing is just kind of going to the very end here. So let's go here, right? So let's start.
Wait.
Back, no. You are very not done yet. You just started. Okay, thing 8 equals 8, right? Line 7. Okay, and then at some point I create this variable called uthing. You want to draw the rest of the diagram out for me and show me where thing becomes 9?
Repeat again, please.
I'm sorry.
Can you repeat again?
Yeah, sure. I mean, just like so on line 7, right? Thing equals 8.
Thing equals to 8.
9.
Right. Here on line 7.
9.
You see that, right?
Yeah.
Cool. So I drew that part out for you, right? And then my question to you now is, okay, at some point we create this variable called uthing, right? And then at some point we change the uthing. So just draw out for me like how the change happens. And when you came on the board, you very confidently erase the 8 and put a 9 here, right? I just want to know where in this function do you see that happen?
Here on line 10.
Well, this is the console log, right? I'm not changing the variable thing here at all, right? I'm just printing it out.
Because thing
So thing is 8 on line 7, and you're saying by the time it gets to line 10, it's now 9. So I'm asking you, where does that change happen? On which line does that change happen?
Because new thing equals to thing, and new thing changes to 9.
Okay, so draw out for me that chain of reactions, if you will. I mean, look, like I know, like a lot of you were confident doing this, but like this is what you're doing in a workshop, right? Like you need to understand it at this level where you're very confidently saying, "Let me just draw the relationships here," because you're going to have to. Otherwise, you are just kind of guessing at that point if you can't draw it out. Okay, so I don't see a 9 anywhere on this page. So where does the 9 come from?
To line 4.
Line 4. Okay, so new thing plus or equal 1. Okay, so what is new thing then?
New thing equals to 2 now.
Well, so where do I? So on line 2 is where I define new thing, right?
New thing equals to 3.
Okay, so draw that out for me. Where does new thing equal to thing? What is that render to? So 8, okay, and then so that's line 2, right? And then on line 4, what happens?
Is it possible that new thing can print out 2 different numbers?
I'm sorry?
8 and 9?
I'm sorry.
Because on line 4, new thing is going to print out 9.
Okay,
Right.
so you're gonna make that 9, right?
So is it possible to print out 8 and 9?
No, a variable can only be one thing at a time.
So it's going to.
Oh.
So new thing is going to be 9.
If you think so, right now.
It's 9.
Okay, and so now we are where Alex got to, right? And so then, okay, so after line 4, that's your diagram, right? New thing is 8, or sorry, thing is 8, new thing is 9.
It's 9.
Okay, and then by the time we finish this function, we go to line 10. You came up here earlier, you said now thing is 9. So where does that happen now?
I really know that it doesn't have to change. When you cancel out, it doesn't change to print out the same thing.
Yeah, console log doesn't change anything. It's just literally just printing out what the value is at that moment in time.
So it's gonna stay 9.
Does it have?
So is thing 8 or 9 on line 10?
8. I think it's 8.
Right, and I mean, if you look at a chart, right, like rather than asking you, I just say, is your chart correct? You say yes. I say, wait, what do you think? What is it going to? Okay, so now we're back to 8 now. Okay. Does anyone else think it's 9? Yeah. What?
I have a question.
Yeah.
If you,
You have a seat, by the way. Sorry. Yeah.
so when you're setting new thing to thing,
Yep.
is that passing by reference?
Yep.
So it would be.
So remember, objects, which includes array, functions, all that stuff, pass by what? Reference, right? Everyone's looking at the same, it's a Google Doc, right? Imagine it's like a Google Doc. Everyone's looking at the same exact thing, right? What kind of data type is 8? Number, primitive, same thing, right? So objects pass by reference, primitive pass by value. Okay, and what does pass by value mean? Yeah, Jason?
That it creates its own standalone entity. That's not the word.
Yeah.
It copies it.
Yeah, exactly. Whenever you're referencing a primitive, I mean, this might do more harm than it's good. But remember how, like, when we were trying to reference an array, we dot sliced it whenever we want to make our own copy? Primitive does that automatically. It does like a quote unquote dot slice or a dot copy, whatever it is, right? So every time you're referencing something that's a primitive, it actually just copies itself, right? So that's why, if I go back to here, right? If I was to kind of draw this, draw the order in which JavaScript sees this, right? Once again, we go back to our old, like the flow is actually going to look very similar to what we have for dot slice, right? Because on line 2 there, we're saying new thing equals thing. Okay, great. I have a left to right thing. I see an assignment there. Let me evaluate the right hand side first, right? What is thing? Oh, thing's 8, right? But it's a primitive, which means I actually need to make my own copy of 8 down here, right? And this 8 is going to be captured by what? This variable called new thing, right? And so now, given that I've drawn this diagram correctly, on line 4 there, I increment new thing by 1, which gives me 9, and then I print out, and now my printout thing here on line 10, well, I mean, it's pretty clear, right? Like, if my diagram's correct, then thing just points to 8. There's no other possible arrows pointing to and from it. Right, so this is why drawing a diagram is, in my view, the best way to kind of reason through a lot of this is because if your diagram is correct, like, you should only ever have one arrow pointing in one place, and that's your answer. Okay? So I'll finish up the slides, but I mean, I think this is pretty much that's pretty much like the heart of the lecture here, right? Which is just that, when it comes to an object, if I pass it back and forth, I'm passing the actual thing, unless I make a copy of it with .slice or something else similar. But when I'm trying to deal with a primitive, sorry, this is showing that the object works the same way as an array. But when I'm dealing with a primitive here, I'm actually just always by default creating a copy, right? At no point am I ever pointing to the same thing. And in fact, if you read that second sentence here, 2 variables can never point to the same actual number in a computer's memory. Like from a basic foundational CS perspective, you can't do that. And that's why that's why in JavaScript we're always creating a copy of a value when it comes to primitives. Yeah, or Alex. Yeah.
Is that, I'm not sure exactly how it would affect it, but like does scope affect that? Like if like there was an array that you assign in one function but it's like outside of the scope of another one, would like change it?
I mean, I guess in the code example earlier we were doing there was an array in a function scope, right? So I guess like, can you write up an example or just like not right now, but like like later if you can code up in REPL like an example snippet, we can put it on the board and then we can kind of talk about how that diagram will look.
I can try. I think the thing I don't understand scope, so.
And Claire?
I just want to look at that problem we did at the beginning. At some point.
Sure. Yeah. Cool. And then strings are what kind of data types? Primitive. So they also pass by what? Value.
Okay.
Cool. All right. So in this case, we have this original string called hello, right? We pass it into a function str. We add the word world to it. But remember, it's a copy of the word hello, right? So the original is still hello, and the new one is hello world. But the old one is always going to be hello because we can never change that one, unless of course we do what?
Wait, can you repeat what you just said?
Yep.
Sorry.
How can we change the value of this string variable here? Reassigning. That's the only way we can ever change it, right? It's a primitive data type, so the only way we can ever change this is to reassign, right? Which means we need to, at some point in this code, do a string equals.
Okay, right.
That's the only way we can ever change a primitive, right? With an object, we can add keys, we can delete keys, we can do all this fancy stuff, and it changes it kind of behind the scenes. With a primitive type, we always have to reassign. That's the only way you can ever change a primitive. Yeah?
So is it a fair, characterization that this really comes into play with objects? And your concern is whether you're changing the original or creating a new?
I mean, it also comes into play with like numbers, right? Like the idea is that like if I have a counter for something, right, and I throw it around different places, if I pass in just a number, like for example, if I want to, figure out how many times something runs, right? I have a counter variable, right? I give it to one function and it runs like 10 times and it increments the counter 10 times. Well, I'll never see that change because my original counter outside of that function never changes. So let's just say I have this guy, this guy here, right? Let's say this number is 3, right? Let's say it's a counter, right? I put it in here. We increment it a bunch of times. Well, this never changes, right? So in that case, like it does work in commerce too, where like we can't assume if I give a number to a function that they're going to be able to change that number. In fact, they by definition cannot change that number. And then, I mean, this is just, this one you can look at on your own. I mean, it's basically like a longer form of what we did on the board. The logic is pretty much the same. But yeah, I mean, this is kind of like the main takeaways, right? Primitives are value. Objects are reference, right? That's just like the heart of what we're trying to talk about here today. Redefining, they call it redefining. I say reassigning, whatever you want to call it. Slicing, Pascal. Slicing, you're just creating a brand new variable, right? It's like it is reassigning, but just like with like different, with different kind of a syntax there. And then yeah, pass by reference versus pass by value. It's not something that you use. It's just like something that's there that's gonna use you probably eventually. Like it's gonna be there regardless. It's not like, oh, I'll just avoid ever using a for loop and I can be really happy, right? It's like, no, like you can't not use this. This is written into like the foundation of JavaScript. It's gonna pop up. Very good. All right, cool. So, okay, cool. So that's the end of the lecture.